Hey, my name is Alex, and this is lesson 13 for 7th grade math. For number 1 here, you simplify this. It's x to the power of negative 3, and when you have a negative exponent, you're going to basically take out the exponent by making the reciprocal. So it's going to be 1 over x to the power of 3. When you have a negative exponent in the numerator, then just take the reciprocal. And it gets rid of the negative in the exponent. But when you have a negative exponent in the denominator, it's the same thing. Just take the reciprocal, get rid of the negative. So this would become just x to the power of a. So using that, number 2 here, it's 3 times x to the power of negative 3 over x to the power of negative 4. So you could first make this a little easier by getting rid of the negatives, so this would become 3x to the power of 4 over x to the power of 3. And then here, you could use previous knowledge of exponents. And if you don't remember, if you have the same base, then you could subtract the exponents. So this would become 3 times x. Here, number 9, we have x to the power of negative 5 over x to the power of negative 2. And instead of number 2, you could skip a step by using this directly to make it a bit easier. So since we have the same base, we could do this, and the base would be x, and the exponent would be negative 5 minus negative 2, which is just negative 5 plus 2, which is negative 3. So your answer for number 9 is negative x to the power of negative 3, or 1 over x to the power of 3. Number 10 is 4x power of negative 2 over 2x. And instead of like number 9, we don't have a similar base, so we can't do what we did here. Instead, we should get rid of this negative here. So it will become 1 over 2x times 4x squared. This also simplifies to 2x times 16x squared, or just 1 over 36 or 32 x cubed. Okay, for this next part, we need to simplify the binomial by factoring. So number 1, we have a leading coefficient of 1. So that makes it a lot easier. So that means that here we need to find the factors of 2 that add up to 3. So the factors of 2 are only 2 and 1. These add up to 3, so we know it's right. So it's going to be x plus 2 times x plus 1. Okay, number 2, same thing as here. We have a leading coefficient of 1. So we need to find the factors of 3 that add up to negative 4. Factors of 3 are 3 and 1, but if you realize 3 plus 1 is not negative 4, it's 4. To get a sum to a negative number, we need 2 negative numbers. So it's going to be negative 3, negative 1. We can't have negative 3 or 1 because that would multiply to a negative number, which 3 is not. So we know that it needs to be 2 negative numbers. And the only factors of 3 are 3 and 1. So we know it's negative 3 and negative 1. So it's going to be x minus 3 times x minus 1 for number 2. Number 5 here, same thing, x squared plus 16x plus 64. When you find the factors, let me write it here. factors of 64 that add up to 16. So that would be 1, 64, 2, 32. Um, there's no factor with 3, but 4, and I think it's 16. And then we have 8 and 8. So here, if you look, 1 plus 64 is 65, so that's not it. 2 plus 32 is 34, so that's not it. 4 plus 16 is 20, so that's not it. But here we have 8 plus 8, which is 16. So this means that this factors to 8, x plus 8 times x plus 8, or just x plus 8 squared. Okay. The next portion is using scientific notation. So scientific notation is used when they're really big numbers, really small numbers, and you want to make it easier to work with. So to do that, you need to make sure that there's only one number on the left side of the decimal, and you multiply that by 10, raise to the power of the number of decimal places that you moved. So here, I'll show you here, number 1. We're going to move the decimal place over 1, 2, 3, 4, 5, 6, 7 places to the left. We stop here because there's only one number on the left side of the decimal, so this becomes 4.259 times 10 to the power of 7. And 7 because that's the number of places that we moved over. Number 2 is a little different than number 1 because it's a really small number. So here, we need to move the decimal place to the right. So we move it 1, 2, 3, 4, 5 places. So this becomes 5.74 times 10 to the power of negative 5. This is negative 5 here because when you're moving to the right, then you need a negative exponent for the 10. If you're moving to the left, then you need a positive exponent. Okay. Here, number 9, we have 80,760,000. So just like number 1, you need to move the decimal over to the left. 1, 2, 3, 4, 5, 6, 7. You move it 7 places to the left, so it's 8.076 times 10 to the power of 7. Is 7 places moved over. Number 10 here. Number 10 is already in scientific notation, but they want you to change it into standard notation. So this is 8.5 times 10 to the power of 2, or just 100. And you could work backwards. So 8.5, we need to move the decimal over to the right 2 places because it's the opposite, right? So it's 1, 2. So it's 850. That's your answer for number 10.